Welcome to assignment 4. I'm so glad you made it so far. Good job. Um, in assignment 4, we're going to keep it very simple. Only three things we need to talk about. We need to talk about what is speed and velocity. We need to talk about an example of how to calculate that. And then we're going to talk about how to read a graph. Very simple and straightforward. Let's get into action. So, what is speed and what is velocity? I'm sure some of you guys already have some idea about what speed is. Speed is nothing but how fast or slow something is going. How fast or slow an object is moving. As simple as that. And if you remember from your everyday language, how do you say speed? You say somebody is going 70 miles per hour. So there is distance and there is time in it. And so the equation of the speed has two things. You take the distance, the total distance, and you divide that by total time that it took to cover that distance. That's how you get speed. As simple as that. For example, if you travel 70 miles in 1 hour, what is your speed? It's just speed is gonna be 70 miles divided by 1 hour, because that was your time. That gives you 70 miles per hour. Ta-da, done. But what is velocity? That seems new. That's something which we don't use in our everyday language. What's a velocity? Well, velocity is very similar to speed. It is speed, but in a specific direction. So, how do you write this? So, you write speed in a specific or definite, whatever word you prefer, direction. That's what velocity is. So for example, this bus over here, this Boston Public School bus, this is going, say for example, 70 miles per hour right now. But if that's all I tell you, that this is going 70 miles per hour, all you know is the speed. But if I tell you that this bus is going 70 miles per hour to the east, then, or to the west, yeah, to the west in this case, sorry. West is to the left. So to the west, then you know the velocity, not just the speed. And just the way you have an equation for speed, like over here, similarly you have an equation for velocity too. And it's pretty similar. Velocity is displacement divided by time. So displacement and divide that by time. That's your equation, the mathematical equation for velocity. And again, how you express it by saying something is going, for example, 70 miles per hour to the west. Or as you will see in our future classes, we will be using positive and negatives. So when something goes to the left, we say negative, something goes to the right, we say positive. So if the bus is going to the left, we'll say negative 70 miles per hour is the velocity. Whereas speed is just 70 miles per hour. Speed is never positive or negative. It's just the number, which is actually positive, but it can never be negative. Whereas velocity can be negative if it's going to the left or if it's going down, but positive if it's going to the right or going up. We'll talk more about this later. But for now, this is what you should know. What is speed and what is velocity? If you remember from previous videos, velocity is a vector because it has a direction, whereas speed is a scalar because it only has a number. There is no direction to speed. Awesome. Let's move on. This should help you do question 1. And when the speed changes, that's when we say, or the velocity changes actually, that's when we say that the acceleration has happened. So speed could remain the same, but if you change your direction, then your velocity has changed. And that's when we say that acceleration happens. And this should help you do your first 2 questions in your assignment. Moving on, let's do an example of how to find speed. We just did an example before, but let's do another good example. So this is me, my best friend David, and Lizzie from a race that we recently ran. And let's just say that we ran 10 kilometers in that race. So I'm only giving you my data. So Mr. Raj ran 10 kilometers in 50 minutes. That's what this table is basically telling you. And the question is, there's two questions. The first question is, what was my speed? And the word we use is the average speed, because when you're running a race, you could start very fast but go slow, then go fast, depends on how much stamina you have. So what we're really looking at is the average, not the speed in the moment, but on an average, what was my speed for the whole race. So let's see. I know that speed, or average speed, needs total distance, and you divide that by total time. What's my total distance from the table? Well, it's 10 kilometers. So you take 10 kilometers, you divide this by total time, which was 50 minutes. And if you do that in your calculator, you should get 1/5, which is 0.2. So what my speed is 0.2 kilometer every minute. Be careful about the units here, because you're dividing minutes here in denominator. The speed is in kilometer per minute, which makes sense. If you're running 0.2 kilometer every minute, and if you add that 50 times, because there's 50 minutes, then you should get to 10 kilometers. Aha, that was question 1. Easy peasy. Just divide the kilometer by minutes. Here is a more fun question though, using the unit conversion that we just learned in the previous assignment. What is my speed in kilometer per hour? So not in minutes, but in hours. And to do this, the first thing you need to know is how to convert this time into hours. Because if you can convert 50 minutes into hours, then you can again use the same equation, 10 divided by whatever number of hours that I took to run this 10 kilometer. How do I do that? So if I ask you how many hours are in 30 minutes, you will say half, because 30 minutes is half an hour. And you're right, it's half an hour. But how do you get that information? How do you know it's half? Well, what you did, which you didn't realize, was you divided 30 minutes by 60 minutes, because there are 60 minutes in an hour. And if you divide 30 by 60, what do you get? You get half an hour. There you go. Using the same logic, if you have 50 minutes and I ask you how much is that in an hour, well, you divide 50 by 60, and that should give you 5/6, which, let me get my calculator out again. 50 divided by 60 will be 0.83. So that gives you 0.83 hour, which makes sense because 50 minutes is not 1 hour for sure. We know it's less than 1 hour. So this number should be less than 1. And that makes sense. And now that I know this, I can find speed very, very easily. Now that I know that 50 minutes is equal to 0.8 hours, 83 hours, what I can do is the same equation. Distance, 10 kilometer for speed divided by time. But in here now, I use the hours rather than the minutes. So just H is enough for hours, actually, not H, R. Okay, let me correct that real quick. H is the symbol for hours. And this gives you what? Well, 10 divided by 0.83, let's see, 10 divided by 0.83 is 12.04. So 12.04 kilometers per hour. Be very careful about that. So that's one way to solve this question. There is another way to solve this question, which a student actually taught me when I was doing this. You know the speed in kilometer per minute. What happens? How many minutes are there in 1 hour? It's 60. So if I already know the speed in kilometer per minute, and if I multiply this by 60, that should give me the speed in kilometer per hour. And I would encourage you to do that, and you should see that you should get the same number. But I'll let the viewer do this themselves, okay? So there's two ways to do this. One, the standard way, and one fast and short way to do it. All right, moving on. The last topic for this assignment. Let's see what we have here. You have three cars here. Let's just call this car orange, this one yellow, this one black. And these three cars are racing against each other, okay? And what I have on the right is a graph. The x-axis has time, 1 second, 2 second, 3 second, 4 second, whereas the y-axis has 10 meter, 20 meter, 30 meter, 40 meter going on. And the question is, well, the question is not there yet. Let's just say this is the orange car. Actually, you know what? Let me make it orange because finally I can do that on my iPad. So let's just say this is the orange car and this is the yellow car and this is the black car. This graph, basically these three straight lines represent these three cars and they all are moving at a constant speed basically in this case. That's why it's a straight line. Anytime you see a straight line for a position time graph, that means it's a constant speed. And the question is which car is moving the fastest. So you can look at the picture and you can already make a guess that it's yellow. But how do I actually physics wise describe it? So see this thing, okay? How do I know yellow is the fastest? What this line is representing is as the time is passing at what position these cars are. So for example, at 1 second, the orange car is over here, is at this position, which might be what, 4 meters? Whereas, and this was 0 second. So 0 second, everybody was at the same starting point. But at 1 second, the orange car has reached 4 meters. But at the same 1 second, the black car has reached maybe 6 meters. But at the same 1 second, this yellow car is almost at 10 meters. So as time went from 0 to 1, we can already see that the yellow car has covered more distance. And if you see for 2 seconds, same. For 2 seconds, this orange car has done maybe 6 meters. But this black car at 2 seconds has done maybe 12 meters. But this yellow car at 2 seconds, oh my god, it's already at 20 meters. So as you can see, as the time is passing, this yellow car is covering more and more distance compared to these guys who are slightly flat. And this is true any case. Like I can give you 10 different cars and you can still tell which one is fastest, because whichever is the steeper one will always be the faster one, because they're covering more and more distance on a faster rate. That was a bad move, but you know what I mean. Okay. So yeah, hopefully this should help you do the last question. But here's my fun question to you. What if this was the car? What can you say about this new car? Actually, let me give it another color. What can you say about the green car? Well, the green car is definitely not in the same picture because it's already at 35 meters. But the fun thing about the green car is as the time is passing, this green car is not moving at all because it's the same location, 35 meters, as the time passes. So if it's a flat line, that means the speed is 0 because you're not moving at all. That's why as the time is passing, here, 3 to 4 seconds, your position remains the same. Your position is not changing. You're still at the same place. That's why I say that you're not moving. All right, that should help you do all the questions. Good luck and see you in assignment 5. So one more thing, guys, that I didn't discuss in this previous question is we discussed about speed, but what about velocity? Like if I run a race, right, say I start from a certain point, I run a race and come back to the same point, what's my average velocity if I run through the whole thing and come back? Remember, velocity is what? Velocity is displacement divided by time. And if you come back to the same spot, if your initial position and your final position is at the same place, your displacement is just 0 because there is no gap between the initial point and the final point. Mind you, your distance is not 0 because you still ran 10 kilometers. But since you landed up at the same spot, your displacement is 0. So if divide 0 by anything, it's just 0. So that's why your average velocity in this case, if I'm running a race, would be 0 if I come back to the same place. And also think about this in terms of the definition of velocity. It's speed in a specific direction. But if you ran the whole race and came back to the same spot, you did not go in any specific direction. So on an average, you're not moving in any direction. Same way, if I'm standing here and I go back and forth, even though I'm moving and I have speed, I'm still going back and forth at the same spot. So my average velocity would be zero because my displacement is zero because I'm at the same location. I go forward, come back, go backward, come back. And that just makes my displacement zero every cycle. So that's why the velocity in this case would be zero, or the average velocity, I should say, in this case is zero because you came back to the same spot. And that's one concept that will be very helpful in the assignment as well, that when you're doing it, if you come back to the same spot, displacement is zero. If displacement is zero, velocity is also zero.